Okay, hello people. So in this video we will be talking about how to implement std thread using Win32 API. I'm not going to be following the book. I just will dedicate a couple of hours and try to do the same as std thread does and try to understand basically how do we pass arbitrary lambda functions to a thread. Because if you take a look at the Win32 API, what it does is takes the function with a specific signature, so you won't be able to pass any other lambda from outside. And the return value should be like unsigned 32-bit integer, and the argument should be a void pointer. So we'll try to play around with that and yeah, basically make our own version of std thread. Yeah, without further ado, let's just jump straight into coding. Okay, so what I have to do, what I want to do is, yeah, and probably I have to say a couple words on what we have covered in the previous episode, and we were talking about transferring the ownership of different threads using the move semantic, and I implemented like a concurrent accumulate. If you're familiar with std accumulate function, that's exactly the same but multi-threaded. And if you're not, std accumulate basically takes a sequence and produces the sum of all the elements in the sequence. And the concurrent accumulation, what it does is just creates multiple threads and computes the sum of some elements on one thread, then some other elements on a different thread, etc. And then it sums everything together and outputs the result. And at the end, I'm joining all the threads. So, for example, let's assume that we have a sequence of 100 elements, and we can split it into 4 different chunks, and each chunk will have 25 elements. And to speed up the process of computing the sum, we could for example, spawn 4 different threads and compute the sum of 25 elements on each thread, and then when they are done, when they are joined, we can sum everything together. And that's what I am doing here. I'm just gathering the results of computations. Yeah, and that's where we left off. Yeah, but in this video I will try to make my own version of std thread. So I will probably call it like Win32 thread, something like this. But we'll get to it later a little bit, and I will create like a separate file. But what I want to take a look at this function. You can Google for it on the Win32. It's like a Win32 API. And what it does is creates a thread, and let me bring my browser so we can read about it together, because we'll need that function in order actually to create a thread. So create a thread to execute within the virtual address space of the colon process, blah blah blah. The pointer to the security attribute, and let's create a thread. And later I will create like an additional file. Maybe I can even do it right now. Let's see, maybe I can add a new item. 62 thread. And that's gonna be .h. I will put it here. Okay. And here what I will do is oh, my typing skills is awful. My typing skills are awful today, so I apologize for that. Thread. Okay, so we'll need that, but for now it's gonna be empty. I just want to sketch out the usage code. There is a security attribute. We don't care about it, so we can pass null, I assume. The initial size of the stack in bytes, the system round this value to the nearest page. Okay, so we can use the default stack, so that would be correct, but we can always come back to it later and reset the stack size. Okay, and that would be the thread function, and I will have to copy it. And you will see later that that actually is a problem, because the function which we executed by the thread has a particular signature, and it cannot be changed. But if you remember from std thread, what it does is it takes any other function and an arbitrary amount of parameters, so we can pass pretty much everything to the thread when you create a thread. So we'll have to figure out how to actually solve that problem. That would be the most complicated part, but we'll get there. Okay, and that's gonna be, I will remove that, we don't need it, and I can probably name it to void pointer. Okay, let's stick with that for now. So that's gonna be our thread procedure, and we would have to pass it here. Oops, no, I want to go back. Okay, let me move the microphone a little bit closer to the mouse, because I'm not sure whether you can hear me well. I hope so. Let me check. Okay. Pointed to the variable to be passed to a thread, and let's just create some kind of a variable, and 12, and then we pass the address of v, but we would have to probably convert it manually, so that would be fine. Okay. Yeah, and eventually I would have to include this file. Oops. Win32 thread, and it should have yeah, we should use double quotes, because otherwise instead of angle brackets, that's how they called, not sure. The flags that controls the creation of the thread, so if you pass 0, then the thread runs immediately after the creation. So and I assume that's what we want, right? So we pass 0, and that receives this thread identifier. So I assume we have to capture the thread ID. Thread ID, okay. So we can remove that. So you see it already, like, I don't know what the right word, but what we should do, like, you see already that thread is represented by two variables, basically, the thread ID and the thread handle. So here we can, like, create a structure and we can say, okay, we have an ID and we have a handle, right? And that would be our thread. And for now I'm going with a struct here, but later we can switch to classes. I'm not a huge fan of classes, to be honest, and for me it's way more easier to develop everything with structs, and yeah, but you can always switch to classes if you want. And okay, so here inside the procedure, what we do, and let me actually parameter. So I will cast back to an integer the parameter, and I will try to print it out. Let's build the program. There are some warnings, but they are coming from the things that we were doing previously, so it's not related to the thread structure that we are writing currently. Okay. And we can execute it right now, but we won't be able to see anything. Yes, because we would have to join the thread. And it behaves actually weirdly, but if I put a breakpoint here and then I release, the program is running, which means that we execute in the threads that we have created. We are not currently on the main thread. So that's a little bit weird, and we have the same behavior with std thread as well. There is a function called wait for multiple objects. And what it does is basically, I'm not sure, probably there is a better function which does exactly the thing that we want, but it will work. Like, I just want to sketch out the structure, and we can always polish it in the future. So what I want is to find a way how we can join the thread, exactly the same as std thread does, right? Because we create a thread and we join the thread at the end. And it takes some procedure and some parameters. So what we would have to do is we kind of have to figure out how do we do it in the Win32 API. And we would need this function, and another would be close handle, because the create thread function returns as a handle, and at the end of the execution we would have to close the handle, obviously. So let me read a bit about this function. Waits until one or all of the specified objects are in the signal state, or the timeout interval elapses. The number of object handles in the array pointed by handles. Okay, so what we would have to do is we would have to specify and count one, since we created only one thread or object, and it takes the array, so we would have to pass an address of our thread because we don't have an array, right? An array of object handles. For a list of object types whose handle can be specified, see the following remark section. The array can contain handles to objects of different types. It may not contain multiple copies of the same handle. If one of these handles is closed while the wait is still pending, the function's behavior is undefined. The handle must have the synchronized access right. Okay. The bwait. Okay, so the next parameter would be bwait all. If it is true, the function returns when the state of all objects in the handles array is signaled, which means when they are finished, I assume. So we'll try to pass through, and if it turned out to be not like reliable, we can always switch to false and try different approaches. Okay, the false, the function returns when the state of any one of the objects is set to be signaled. Maybe false work actually as well, because since we are creating only one thread, yeah, but we'll see. The timeout interval in milliseconds. If a non-zero value is specified, the function waits until the specified objects are signaled or the interval elapses. Milliseconds is 0. The function does not enter a wait state if the specified objects are not signaled. Is infinite, the function will return only when the specified objects are signaled. Yeah, we'll have to read more about it, but I think that will do the trick that we want. let's see. Okay, so here is our parameter, but right now we print in the address. Yeah, and that's because I'm not referencing the value, the pointer to retrieve a value. And we can take a look, and here is our value. Right, and let me put false here. I just want to try what happens. Okay, so that's the same. Probably we have to use false since we're using only one. We are not creating multiple threads. Yeah, let me read more about it. If the function succeeds, the return value indicates the event that caused the function to return. Is defined. Okay. Is signaled. The function says wait operation is completed. Okay, mutex says the wait function can specify handles of any of the following object types: array process, thread, mutex, memory resource notification. Okay, so that will work for threads as well, and waitable timers. We have like a different function. Yeah, let me take a look at the wait functions. What does this one do? One of the specified objects and the signal state is queued to the thread. Okay, so we can go with this function for now, and if it reveals to be problematic, we will have to read more about it. Okay, but let's just start moving the code a bit to the structure that we have. So I will create a constructor here. I will create a constructor, and for now I just want to pass this function and exactly one parameter. So I will grab the signature of the function. Win32 is actually state call, so nothing special. Thread doc. So we'll do that. Std state call, and we can replace it with the pointer, and we will make it as an arg list, and that actually would be an arg list, and we don't have to specify it here. Okay, and we would have to create the destructor as well for the thread, and we'll implement it later since it's not ready right now, but we can put, just for now, this thing here. So what we would do is we will grab thread handle and thread handle, and that would return the thread, or we can set it inside, I hope. So that's supposed to be like a private function, create thread, but for now I'm just sketching the implementation, so everything should be public and easily accessible. So I will do the same. And inside I would have to call this, which returns me a handle, thread handle, and that would be and we can initialize it to default. So that's okay. So this would be the thread procedure, and this would be the arg list. Not even sure whether I have to cast. What are you complaining about? Argument type isn't compatible with parameter of type. Okay, so maybe the problem is that it has to be like a dword. Yeah, okay, makes sense. We can always like convert it, but since we're using the Win32 API, let's stick with that. And what was that actually? Thread ID. Okay. Thread ID. Okay, and that has to be dword as well, or we would have to cast it. And let me check whether we can handle whether we can introduce some error handling. So if the function succeeds, the return value is a handle. If the function fails, the return value is null. Okay. So just for simplicity, what we can do is we can check if that's equals null, we can throw an exception, right? That's all great. And here, what we would do is thread. Okay, we can even do this. Thread, and then that would be the result. And then the result. And we return the result here, and we call the create thread function. But our own version, and we forward the std procedure and the argument list. So that would be fine, and we don't need an additional parenthesis. Yeah, so that should work. Okay, so and now we can remove, or rather we can move this a little bit here, and we can mark it as a lambda. So the thread procedure, the word, and then we would have to accept the argument list, and that would be the lambda. And then we saying, okay, let's take an argument list, pass it back to the parameters that we are passing, because we know what we are passing already, and reference it. And here we don't need this crap anymore. We can create an instance of std thread. And we will pass like the thread procedure, the value. Have to do that, and everything will work correctly, I hope. But that's not kind of the way to go, because we'll have to introduce a function, something like thread wait, so we can an analogy to std join, std thread join, right? But let me compile and see, and let's just step through it to make sure that everything works as expected. Okay, so we creating a thread. Yeah, we successfully created. Take a look at the thread, and Then we initialize it, and if you take a look at this, I know the font size is pretty tiny, but yeah. And then we should step inside the constructor, we wait for it, and we close the handle, and here is our result. Right. Right, okay. So what else do we need to do? I will create like a default constructor which doesn't create a thread, so we can use this thread t. Well, I don't know actually why do we even need that, but just I think it's a good practice to provide a default constructor. Now we would have to introduce the method something like wait for the thread to finish, wait for thread. We can even like name it explicitly, wait for thread, and that would be the void function, and that would be a member as well. Yeah, and it basically should do the same thing that we're doing here, and at the end it should set thread to something like this. And I was going to mark it cons, but usually we can't because we clearing out the value. Let me put a debug break here. And let's just put a breakpoint and step inside. Right, and let's put a breakpoint here, and then we're waiting for the thread, and we clearing out the values, debug break, and then we go to the destructor, but it shouldn't do anything, and we print the value. Yeah, and actually what we would have to do, we would have to check. Okay, so that's correct. We'd have to introduce like a function, but that would be private as well. Is finished, or yeah, okay, is finished. That would be the const, and let's make it boolean, but actually I prefer using this because like because it's better for our CPU if the value that you are operating on is aligned by 4 bytes boundary or by 8 bytes, so basically 4 bytes aligned, right? Instead of 1 byte. So it's better to do this, I think. And then we return thread, and we can make a result. Thread ID equals 0, and we return the result. And we could even simplify it. It doesn't have to be less code. Is better always. So we would have to check whether the if the thread is finished, and again, like for those people who don't understand what I'm doing, I highly encourage you to take a look at the STD thread, because basically we implementing the same idea, because in the destructor itself we are checking whether this thread has been joined or whether it can, whether we are checking whether the thread can be joined, right? And if it is, we throw an exception. And I just want to implement the same behavior. So when we got to the destructor and the thread didn't finish its execution, we will throw an exception, right? So that the user has to remember that he should call this function all the time after the creation of the thread. So if it's not finished, then we will throw an exception, right? But here, what we can do, if it's finished, okay, so that would be the right way of doing things, and we can remove that from the destructor. So basically we can call this function multiple times, and we want to prevent from waiting for an object and closing the handle, right? So basically check whether, since we are clearing the value, we have to, on the next function call, the ID would be 0, and thus we won't enter this if statement. So let me try. We have a couple of warnings, but okay, we'll take a look at them later. I'll put a couple of breakpoints and see what happens. So we call the function wait for the thread, and yeah, ID isn't equal to 0 because the ID is 28,668 currently. That's the ID of the thread, and we wait for an object, load the handle, yeah. But then when we call it once again, the ID will be 0 already, and we skip. And then we go to the destructor and we don't throw an exception because the thread was already joined or finished, right? Okay, so that's correct. You would have to implement the move semantic, and I will do it right away. Remember that the std thread cannot be copied, so that's really important. We can only transfer the ownership, and thus we have to delete copy constructor and copy assignment operator, and that's what I'm going to do right now as well. So I will grab that. Oops. Delete, and that should be deleted as well. And the move semantic source okay. So that should return a reference equals return this, and we would have to do something here, but let me compile first and see that everything works fine, and yes, it is. So function assume not to throw an exception, but it does. I'm not sure that I fully understand. Okay, we'll skip that for now, but and if you take a look at what the std thread does, it basically uses in exchange, std exchange, and we can implement our own, but it takes like the first value by reference, and the second is R value, or in this case I think it's gonna be universal value. I'm not sure, but we'll use the same approach, kind of. Yeah, I will explain. So basically what we can do, exchange std exchange, and what we have to do is thread, and that would be correct, and then what we would have to do is initialize our thread yes, I think so, that's correct. Let me build. Yeah, okay, so what we are doing here is we're taking the source, like the object that we are moving the ownership from, like that can be even called like from a source, like doesn't really matter, and we clearing in the values of that object, so we won't be able to like operate on it in the future, and we initializing the values of this thread with the from. And actually I think it will be possible to implement exchange type name t, right, and what I would do is t, I just want to try, yeah, exchange, so the first is going to be old, and that's going to be the value that we are trying to clear it with. And we have to like that probably can be a class, right? It doesn't really matter, like, but old object, so we override, okay, so we create in, we move in the value, okay, no, that's not correct. We apply an old, okay, and then what we are doing is we're saying, okay, old equals static cast value, and then we return so that basically should be TMP or something. Old TMP. And that would work. Why are you complaining about things? Oh, probably because I have to include like std int.h or something for the int32 type, but that doesn't really matter since it's a header file and it will be copy pasted directly into the C++ file where we have already all the types defined. So I could replace with my exchange, and let me put a breakpoint just to make sure that that works fine. So we created a thread, and then to do. Okay, we create a new one, thread 0, and then std move thread, and then wait for the thread. I will put a breakpoint and let's see what happens. Okay, and let me put a breakpoint here as well. So we're trying to move. We have an old and the value, and that's the old. So we move in the we creating like a temporary old old TMP. Okay, we won't be able to take a look at that in the debug in the watch window. We override the old and then we return the old TMP, and then yes. Okay, so I assume it has like a different ID. Let's go through it again, because I forgot what the idea of the thread before we moved the ownership. So the idea of this thread is 16,976, and if we execute this function, okay, so we preserve the ID, but the from should have 0 in it. Yeah, and it does, which is correct. And here we have our parameter printed out correctly, so that's always great. That's always great, but I think like I can go with exchange. Maybe we can even prevent moving. What we could do instead is say, okay, so from equals, we can say, okay, thread equals from equals this thread from thread. So we can do that. I don't know which one is cleaner, but the behavior would be the same. Okay. And let me remove my exchange. I just only did it for educational purposes. Here what we have to do, we would have to check whether the thread not finished. Then we throw an exception as well, because we cannot move the ownership to the thread which has not finished its execution. It's running, right? Which means that we won't be able to create like a different thread here. So what I'm trying to say is that let's just remove this function, and let's assume that we have thread 1 and we assign some different procedure to this thread block 1 and some different parameter. But then what we are trying to do is we're trying to say, okay, thread 0 equal thread 1, and we want to avoid this situation. Or if, for example, even simpler, okay, like this, right? Now let me think about it more. Yeah, I would have to try. Okay, I would have to try. Let me see. And I would need to copy this code and see what happens if I will try to I'll put a breakpoint, and if it's not finished, we throw an exception from thread, and then thread equals this. We return this. Okay, makes sense to me. Makes sense to me, and I will put the breakpoint here as well. And let's see what happens. Yeah, that's correct. We're making it 0. We can remove those things. We don't need them. We executed the program correctly, but now if we do, for example, this, let's create a different lambda function. Parameter 1, and maybe we can ++v, and that would be thread procedure 1, and procedure 1 we, okay. Yes, we move in, and then we check in whether it's finished, and we throw an exception. Because we cannot do it. It has a procedure assigned to it. We cannot transfer the ownership, right? And I assume this is exactly what std thread does. If it checks whether the thread is joinable, and if it is, it throws an exception. Otherwise, we move. So the behavior is pretty much the same. That is not allowed. But what is allowed is this thread 1, and thread 1, thread 0, and then we have to join thread 1. Oh, right, because it's copy assignment, right? Yeah. Yes, okay. Function was deleted, and that's correct. Because we deleted that intentionally. Procedure 1 and v, which can be a value. That always correct. Okay, we have to pass an address. That's my bad. Okay, that's correct. We're making it. So we assign a new identifier, and then we clearing out the thread, and then we that's bad. That is bad. Okay, so let me take a look what happened. The thread has this ID, and it's not finished. Oh, right, because we couldn't join this. Yeah, because it was yeah, okay, so we created a temporary object of Win32's thread and assigned the procedure to it, right? And we called the destructor. But that should be finished. Okay, let's step through it again. Right, and then we create a thread, right? we've successfully created a thread, and then we move in the ownership. We're certain that, okay, so the from is the one that we created, the temporary object, right? It has this ID. And then I'm clearing out the from. Then I'm returning this. And then I'm calling the destructor for the object that was created here. And for some reason, yeah, that's correct. That's correct. So we are not throwing an exception. All right. Yeah, everything works fine. I just forgot to call for thread 0 as well. That's actually the reason why it would be great to have like a more descriptable error message instead of throwing an exception, because it doesn't help anyhow. Maybe we could print like an ID or something. Let's see, just for debugging, right? We could throw and... Okay, so we... Error or yeah, the terminate is really good name. It's really good name. Maybe I can use it here, and I can throw an exception, but then can do something like some kind of an error message that string stream or sass, but we don't really need that. Thread error the thread hasn't been finished. Thread with ID, so that's gonna be now I'm actually a fan of buffers. Char buffer 10, okay. No. You see, in C++ there are so many ways to implement the same shit. Thread ID hasn't finished its execution. Right, and then we can see out and now if I forget to join or wait for the thread, I should get this error. Okay, oh, yeah. So what we do is we have to call terminate with message. Or we can even do this, like throw this message. Yeah. And if you take a look, error, the thread with ID, this ID hasn't finished its execution. We can even take a look at the handle. ID. That would be enough. It's only for debugging purposes. And there are, if you remember, there are some things like you can, when you create an STD thread, you can ask for the amount of threads supported by your current machine. So I will try to do the same. Open thread. Okay. Close handle, suspend thread, terminate thread. System course. Okay. Threads count. System course. Yeah, we can ask for that, and that should be the const and get system info. Is that the function? So it takes a parameter of type this. C and okay, so we would have to create a system info system info, and what I would do is I will pass it here. System info and take an address. Probably we have to check for some address, but what we're interested here in number of processors. I don't know. I know it's like a little bit misleading name, but still. Result equals sys info number of processors and then result. So that's gonna be our function system course, and we can put a breakpoint and we can ask thread 1 system course, and we can course count, and we can even do this std cout course count. We would do that, and we'll put a breakpoint here. Okay, so we'll query for the system info. Let me put it in as a watch window. So 36 on my machine. Yeah, it's very powerful. And then we return the information and we printing it out to the console. Here is the 36 course count. Okay, but because threads are running on the background, we printing like in a little bit in a weird way. So that's correct. Okay, and that's always great. That's always great. retrieve the pseudo handle for the current thread. I wonder whether it's possible to get current thread ID. Okay. Retrieve the thread identifier. Get current thread ID, and inside the procedure I won't be able to somehow retrieve the information about the current thread. So what we would have to do, oops, I would copy this function and get current thread ID, and that would return me an ID of the current thread. And I would make it static, and no. Oh, you know what I can do? I don't know whether I should make it static or static, and I can put it here. Right, and what we can do, for example, inside this procedure, what we could do, just want to make sure that the ID is the same. Current or this thread ID, Win32 thread, and then get current ID. Oops. Let's build the program. No, I actually want to put a breakpoint. Yeah. Okay, so we are inside. So the ID of the thread is at 29,432. And that should be the correct values that will be printed in the result. Yes, okay. Okay. So, and if I take it output, yes, that's exactly the values that we were looking for, which is fine. This thread ID. That's actually a better name. I will put it into the scope just for fun. Get current thread ID. I think we can't even remove get. It's not necessary. Okay, so we have like all the functionality. That we need in order to move further, and let me just quickly go through it to make sure that we didn't do any stupid mistakes on the way. So we have like an ability to retrieve the ID of the current thread, the system cores, that should be private, so that should be public, that should be private as well, this should be private, and the structure as well. How much time do I have? Okay, so that was only a single hour. And right now what I would have to do is I would try to play around a bit with passing different lambda procedures, lambda functions into the thread. So I would have to create a different constructor, and obviously it will be template procedure, and it will accept an arbitrary number of arguments. args, and yeah, proc would be enough. That's great. Thread. And we can even introduce a concept, but it's not necessary here. So we'll pass a procedure. Come on, Visual Studio. So the procedure, yeah, that's correct, and args, arguments, or rather like arg list. Let me take a look what everything compiles. Yeah, okay. Cannot open include file. Yeah, it happens on occasion. I don't know why, but that's how it is. So what do we know already? That the thread procedure has exactly the same, has a particular signature. Let me go quickly to the procedures that we have, and I will put it here as a reference. So it should return the D word, which is unsigned 32-bit integer, and it should take the void pointer. So if you try to pass any other procedure which has a different signature from this one, it will fail to compile. So what we have to do, and this is what std thread does, is we have only one option left. We have to somehow figure out a way how to pass the procedure itself and all the arguments that we pass to that procedure inside this parameter, inside this void pointer parameter, right? And then inside the procedure itself, we would have to call the function that, okay, arbitrary function that we passed, or just a regular function that we passed from outside, which is an arbitrary function, right? And all the parameters. So arg0, arg1, arg2, arg boom boom boom, arg_n -1, arg_n whatever. So that's what it will do, and we will have to extract all the information from this single parameter. So that's the problem that we are going to solve. So we are able to pass arbitrary procedures. Yeah, and then inside of it, so then we register in this procedure the thread creation, but then inside the procedure itself we call in the one that we passed instead, which has like any signatures that you want and takes any argument that you want. Yeah, so I hope that will be clear. So how do we do that? That would be quite tricky. Well, obviously we'll have to create like let's just mark it like this for now, and we will polish things a bit at the end. So that should have exactly the same signature. Create thread, and what we do, should I pass it like this? probably. Do I actually need to forward? Okay, probably yes I do. So that would be the procedure and std forward arguments arg list. Do I need to use ellipsis like to make an expansion? Okay, so let's try to compile. Was unexpected. Oh. Parameter pack must be expanded in this context. Okay, how? That's what we have to do. Parameter pack. I'm not sure. Okay, let me see. Procedure. I'll just copy. Okay, so that's how I should expand it. And again, this is like what std thread does. Pretty much, I assume. vnpack. Yeah, okay. So we'll have to take a look at that because it's complicated. But I just want to try like and figure out it on my own. How do we do that? So we forward everything. And then we have to, okay, so let's take a look at the arg list size. So, okay, number of arguments. Assume that would be the okay. Let's put a debug break at the end. And make a breakpoint here. And we are not... Okay, we do. Number of arguments. We only have a single argument, but if you pass more... For example, let's remove, okay, so here we have like a lambda function, thread proc, and we can pass t or arg0, and then we can pass like an std string as, and or it can be even i32, and then we can pass maybe something else, but for simplicity let's not gonna do it for now. And we'll return 0. Oh, it's not even necessary. See out. We'll get the thread ID, current thread ID. We already have everything for that. Thread ID, and then we would print the i32 value. And then we would print this string. what are you complaining about? Okay, so maybe we have to see... that's the wrong name actually. Not SRT. So that is fine. Let me try to compile the program, and that should work correctly. And then I'm passing the procedure and the values. We don't have enough values actually. I will pass like 5 and string, right? Red fox. Okay, that should be fine. And right now you can see we have like 2 arguments. So what do? How do we forward them or propagate them to the procedure that to this kind of procedure, which only to this, right? Which only takes the void pointer and returns the D word. That would be tricky, but we would have to take a look at the... Let me find it. It's the D... integer sequence. Integer sequence. No, not a CPP reference. I don't want CPP reference. C++ std integer integer sequence. Okay. So represent an integer sequence can be used to deduce and expand parameter packs in variadic types such as std tuple. Okay, so we would have to create an std tuple, I think. Do we have an example? Make a tuple. And then we can get an index. An integer sequence can be used to deduce and expand parameter packs, and that's exactly what we have here, right? And that's the parameter pack. How do we create a tuple? Std tuple. Okay, class template is the tuple is a fixed size collection. Okay, can we forward, for example, std tuple. Args. Okay, no, I don't know. That would be a lot of struggle. Did they move? Can we move really all of them? I don't know. Arg list. Okay, so we can do that, right? And then, so that's going to be a tuple. And let's print first tuple std get. We know that it is an integer, right? So we can easily apply that tuple std handle. Right now I'm just sketching out. I'm trying to move closer to second. That would be std. Oh, sorry. No, that's fine. You have to provide. Okay, and second. Will that compile? Yes. Okay, it does. Have a link error. Okay, so the first is 5 and the second is red fox. Which is exactly what we want. Okay. I might take a look at the std thread since I don't really know how to do that. So we have, okay, we can get like the elements inside the tuple, but we don't know how many we have. Make index sequence. And that's what I'm supposed to use. An integer sequence can be used to deduce and expand parameter packs in variadic types, such as std tuple that are passed as arguments to a function. Okay. Okay, so it has to be an index, right? Okay, okay. N. To make an index sequence, yeah, we would have to, okay, make an index sequence. For parameter pack, use index sequence for t. Size of t, okay. 1 plus size of arcs. That's what we want to do? What would be the difference if I put arcs here? I'll compile, and that would be our index sequence. Yeah, you see, I love struggling a lot. Okay. So the number is 2, which is correct. And the index sequence, we won't be able to take a look, obviously, but it have to be 3. How do I print indices? Yes, okay, obviously I cannot do that. Okay. Create thread procedure. Okay, and we have to make sure that we are not passing. Can it be static? No. Okay. Create thread procedure will return. So this one should be definitely static. Okay, static thread procedure, and that would be like a D word. And that will take the what's going on? Turn 0. Okay. I hate Visual Studio. Oh, sorry. Type name proc. And remember that I told you that we have to somehow retrieve or unpack a tuple. And the reason why it's static is because we don't want to pass this pointer, because it will violate the signature of this function. Oops. Create the thread procedure. Okay. So there's like std invoke. Yeah, we'll take a look at the std invoke function, which basically calls the procedure with the given list of arguments. And how do we get a tuple here? Okay, so we would pass a tuple. We can actually pass a pointer to a tuple, and that's what std thread does, I believe, right? Okay, so we would have to cast it. Okay, let me think. So we can make yeah, I don't know really. Let me take a look. How do we do it in like an actual implementation? I just want to take a look. How do we? So we construct a tuple out of a function. So that's going to be a tuple type, and we create a tuple, and we forward everything, right? The sequence. Okay. So that's what we do. We create a unique pointer. Right. And then we pass a unique pointer here. So yeah, okay, we will go through it at the end and make sure that we do understand everything and me in the first place. But the idea is that we create a unique pointer and we pass the pointer itself. Let me see. Okay, the address, the tuple itself actually. So we create a unique pointer inside this function, and the pointer which contains a tuple of a function and all the arguments that we forwarded, right? So the tuple will contain the function plus all the arguments that we forwarded. And then what we do is we create an index sequence which is going to be the size of all the arguments that we have plus 1, which is exactly like our function plus however many arguments we have. In our case, it's going to be 3 if we have 2 arguments. And we call this procedure which accepts an index sequence, which is basically a sequence of indices, right? And we pass, so we unpack the indices here that's exactly like what we are doing, but instead of type name they use size t, and then we return an address of the function that has the correct signature, because you see it's unsigned int. That's exactly what I've told you before, which is dword. Then we have a state call. Why are you complaining about it? Okay, which is exactly the same as Win32, because Win32 is just a macro for state call. And as a calling convention, it determines how arguments are passed, in which order. I assume, if I remember correctly, arguments are passed to a function from the left to right, or from the right to left, or maybe some other different order. Yeah, but that's... And then we unpack the tuple and we invoke by moving all the arguments. And then we would have to release a unique pointer. Yeah, and that's quite involved. That's quite involved, to be honest. But yeah, let's just try to implement that. So what we would have to do is we would have to make a tuple, or rather we would have to make a unique pointer. Unique pointer, I think it can be an arbitrary pointer. std tuple, well, proc args. Let's maybe let's create a type. I don't know actually. How do we how do we do that? Tuple not even sure whether that would be correct. Okay, it must be expanded. Yeah. So we expand in the template parameter pack. Tuple type. Okay, the tuple, and then what we do, we create a unique pointer out of it. Tuple type, and then tuple. So that's basically proc plus all the arguments, and we call std make unique here, and that would be the tuple type. And what we do here, is we have to create an actual tuple. So we create the tuple and we std forward everything, the procedure, and we forward. We can actually move it on a separate line. And std forward args arg list. And that would be unpacking all the arguments. Redefinition different basic type. Okay. And that's I don't need. Can remove that for now. Okay, so what are you complaining about? Maybe that's... no? So the std forward to the procedure, that's going to be the type. No matching overloaded function found. So we make the unique here, tuple type, we create a tuple procedure, we forward the procedure, and I'm not sure whether that's the right things, the right way of doing things. Arg list. Okay, it was just the wrong type. Yeah, we have to use tuple type. Okay. And then what we do, Well, we can take a look what we have generated, right? Like tuple contents equals tuple get. So we get the value of the unique pointer, and then what we do, since we know that we are passing 3 arguments, that the tuple itself will contain our procedure, and it will contain all the rest of the arguments, and we know that we will have 3 of them, because the first one is the procedure itself, then 5, and then the string red fox. Procedure, and it will come as an address rather than, as an address. But what we'll have to do is use std get. So we'll get the first the second, it's not actually an int, enter it to the t, right? And that will be our value, and that will have an index 1 and std cout, and the string, it will have get to tuple contents std handle, and I will put a breakpoint here. Nope, that's not how it works, unfortunately. Should I no, wait a second. Yeah, I should have the reference, because if you take the get, it returns my pair, my value, which is an address to the tuple, but we will have to get an actual tuple, right? Otherwise, tuple type, and we can do this, and we can do that. We can make a reference out of it. Yeah, okay. Tuple ptr. Sorry, I know what the issue is. So that would be the correct way of doing things. And let's see. So we hit a breakpoint, and then we print. Yeah, okay, so that's the address of this procedure. And even maybe we can get an address. No, we can't. But anyway. Yeah, but that would be the proc, right? So we can take a look at the proc, and yeah, okay. Because we moved. No, we forwarded it. Are we Okay, anyway. So the procedure, then 5, and then the string itself, the red fox. Okay, so that's great. And that's great. And then we would have to pass thread proc thread procedure. Let's make it like this. thread procedure would be create thread proc. We would have to get an address, and we would have, so we retrieve the thread procedure, right? And then we are calling like create thread thread the thread procedure and the tuple. Tuple, no, wait a second. Tuple pointer get. So that's what we will need to do in order to create a thread, and that would be thread handle. No, it actually returns this thread structure, so that should be enough. And then what we would have to do is we would have to release tuple pointer release, but we'll save it for later. Let's compile. Yeah, obviously we have a lot of different errors. We don't have this function defined, so I will put it here, and that would be a function which takes an index sequence, and it shouldn't take any and which returns the void pointer. Okay, let's compile it like this. Cannot convert from void pointer to dword. Yeah, obviously it cannot convert. So what we would have to do is have to get an address of the thread proc with okay. What are you complaining about now? So decal void, okay. Create thread, and that's probably okay. I have to call this one instead. No, wait a second. So for the create thread, I'm passing the procedure and yes, that's not correct. That's not correct. I would have to do this instead. and I would have to pass like a the thread proc, right? And no, not an arg list, but rather tuple pointer get, and then we pass the thread ID and the thread handle. Let me see. Still have a lot of errors. Handle create cannot convert argument 3 from void to okay. It cannot for some reason. Thread procedure. We get an address of this function and we should return 0, that's fine. We've returned the address. Let's just try without any indirection. Try to use this proc instead. So we don't receive anything, and we don't need that, we don't need that, and we don't need that for now. Let's just simplify things. And that'll remove this as well. And let's see what happens. Okay, so that compiles. That compiles without any problems. And we would have to release the pointer, obviously. So here, we have to pass everything. Get. Yeah, okay, so we will experiment with that for a bit, but unable to resolve function overload. Yeah, okay, we have to provide the template. Okay, and we don't know like to which type we would have to cast, so class tuple because remember what we have to do here. We have to invoke the procedure, so our arg list contains, so what we have to do is tuple type so I will cast that our arg list, which would contain the tuple, right? Oops. I mean, obviously we can do a static cast, but that doesn't really matter. Tuple, and that would be a pointer, tuple type, and tuple pointer. And so okay, and then we do this. We std invoke std get. I will do it manually for now, since I know that there will be 3 arguments. Yeah, okay, so I can do this. Maybe I can even do that. The reference, but it's, yeah, it's dangerous to dereference it here, because what I want to do is just to have a reference to the tuple, but we'll do it for now. We'll do it for now, or we can, yeah, okay. Tuple pointer, and it's not actually, okay, the tuple. So we'd have to do the tuple. Maybe we don't even need to release. Okay, so the first element will be the function, the second element is the tuple, and tuple as well. And that's what we do. We probably would have to use move here, and we can use std move. Yeah, for now it will save a lot of time. So moving the function, get tuple move that as well, and move that as well. And that's actually the place where we invoke the function, right? We get the tuple. Probably we have to make sure that the tuple doesn't equal, okay, assertion tuple, and then let's make this, okay, tuple pointer, let's compile and see what happens. Yeah, okay, so we have here the problem. And now, in order for me to do that, I would have to pass like a class tuple type, and size t indices. Right, and then I'm passing the tuple type. Let's not gonna use indices for now. We don't really need them. Tuple type, and we remove that. Tuple type. Okay, so that's correct. Let me compile. Again, it cannot convert. Okay, so that has... Oh, wait a second. Maybe it has to be static as well. Let me try. No, not really. So we get the thread procedure, and this one has to be static. LP void That's the arg list. Okay, so then we have the tuple type. And that should be at the reference. And that should be, okay, let's stick with static cast. And let me take a look where I'm actually, okay, and then thread procedure would be, we'll have to call the function create thread procedure, and we would have to pass the tuple type. Thread proc. So that returns, yeah, it shouldn't be static. Thread proc. What's create? That should be correct, no? And we still have an error, identifier not found. But this is right above it. I'm not getting, oh. So let's see, still complaining about something. That handle, size t, thread procedure, cannot convert argument 3 from void pointer to LP thread start routine. No, that's not going to solve the problem. The problem is the type is incompatible. Yeah. Yeah, okay, so that is correct. And now let me put a breakpoint here. And before moving, I will do the same thing. I will get a tuple, since I already have it. We don't need. And I will do that. I will put a couple of breakpoints here and there. And that well, it should be private first of all. And maybe we can make it static since it doesn't really need to operate on this, right? So, and this has to be, because it operates, it assigns a handle and an ID, so that's why it has to be without static keyword, but about this we don't really care. And this as well is an actual thread procedure that we have. Okay, let's come back to the thread and let's put a breakpoint and see what happens. Failed to link the program. I don't know why it happens for me all the time, but I keep getting link errors. Yeah, so we trying to create a thread. We step inside and trying to create. We get an address. And then we are not executing the procedure right now. It will be actually done when we create the thread. So I put a breakpoint there, and okay, so we execute the procedure, we get the tuple back, we get the reference, and that's bad. That's bad. That is bad. Okay, so let's try again. Yeah, I will remove the reference so we have less code. Yeah, okay, so we creating a thread, and here we printing the address. We should be able to print an address, right? So the tuple is the contains of a procedure plus all the arguments that we forwarded. Then we call the create proc thread proc function, which returns which substitutes this function at compile time with a specific type, right? And then we step inside and we return the address with this particular type. Since, okay, maybe it has to be done in the compile time. Create the thread procedure, and yeah, okay. We release That's weird. We were getting an actual procedure, and we managed to print it, and that was the idea of the thread, I guess, right? But we didn't get an actual string. We got an error before. How is that even possible? Oh, since we are not... that's me. That's... I forgot to call this function. That's dumb. Let me try again. Yeah, we don't have any messages for now. Let me increase a bit. So we printing out the procedure. That's correct. We printing out the first parameter. That's correct. We have 5, and we're printing out the string red fox, which is fine. And then we finish the execution of a thread. And that's actually our thread procedure. And okay, am I still recording? Yes. So let me run it again and go through it. Yep. We are not printing anything inside the procedure itself because we are not calling it. What we have to do is to invoke yeah, I shouldn't be using std at all, and that's not what I need. Okay. Can we access the tuple like this as well? I have never used tuples, but no, probably we cannot. Okay. Oh, but that's complaining about the std invoke function. Yeah, and let me still see whether we can print the tuple. I will comment that out, and yeah, let's see. No, we can't. Okay, so that's complaining about this line. Can I do that? No. Okay. How do I operate on the tuples? Do I have to use like a get all the time? And that's fine. So, invoking. So our procedure would be auto proc get 0 tuple pointer, and then first arg get 1. I'm trying to make everything explicit so you understand, and like, okay, so that would be our i32, and that's gonna be our string, right? Tuple pointer, and then what we do is we pass the procedure and that and this. Okay, so that should work. We'll see whether it's okay. Yeah, okay. And I will put a breakpoint inside an actual procedure to make sure that we execute it. And yes, we do. So, and we printing one more time into the console like the string, the value, and the red fox. And yeah, so we are able to pass the function which has an arbitrary signature, and we were able to pass any amount of arguments. But right now the problem is that we hard-coded the amount of arguments that we have, because we know already that we have only 3, so that's why we can't retrieve. What we have to do instead is to use like this index sequence, so we can use indices instead. So what we would have to do, we would have to follow the same approach. But I guess, I'm not sure. Indices tuple, so that's like the idea, tuple pointer, and then we unpack, and that's what we do, right? That is what we do. So that's going to be the next step. How do we do that? Okay, so auto index sequence. Well, we can do indices. That's indices. Would that be correct? Okay, let me take a look. Thread procedure. But it's like an integer sequence. Indices. Okay. Yeah, I was wrong. Yeah, but let's try. Indices std index sequence. We'd have to create a sequence, and that's going to be 1 plus size of. Oh, actually, we can do. Is it like a make index sequence? Make index sequence. Because we have to pass 1. If we could eliminate that, if we could avoid that, we could have used index sequence instead. But since we have to like add 1, which is understandable, because that would be our procedure, right? Because we can pass on the arguments without a procedure, but how do we retrieve the proc, like the function itself inside the thread procedure? Nobody knows. So we got an indices and indices, and that's what I want to do. We unpacking. No machine overloaded function found. Okay. Yeah, because it has to take an actual index sequence. Index sequence. Indices. Cannot deduce type for auto from overloaded function. Return unable to resolve function overload. I think we have to pass here as well. Let's see. Okay, that's gonna be the tuple type, and So this is a parameter pack. And in passing, I think we have to use the unpacking and that's what I need to do. Okay. Do I even need to pass it? Probably I don't. But then the compiler won't be able to deduce it. Okay, it does. Actually it does, but how do I... So it's 0 or... okay, 0 or more. In this case it will be 0, so that's why it doesn't complain. Right, because if I make sure that we have at least one. Yeah, okay. So the parameter pack indicates that we have 0 or more, I assume, and that's why we would have to pass an indices. So the index, sequence, and indices. So we unpack okay, and here, instead of doing this, what we could do, oops. What we could do is, okay, so we have move, we have get, indices, tuple, expected an expression instead of a type. We don't have, okay, so v tuple pointer. No machine overloaded for function found. Okay, so we take this. Yeah, because we cannot, yeah, we expand into the move. So if you do it this way, we expand in, so we will pass multiple arguments to the move constructor, but that's not what we want to do. We want to pass like the function and all the argument that follow it to the invoke, right? So that would be the correct syntaxes. And we pass an indices. What if I do this? Do I need to expand the pack? No, I don't need. We can even do this tuple, tuple pointer, indices, tuple pointer, because we had an example here, make a tuple, and then we take an index sequence, right? Create a tuple from the array and an index sequence. And we take an array and an index sequence and we create a tuple out of it. So we can basically create a new tuple, tuple type, new tuple. We can have like an old tuple pointer, and we can even do this, make tuple. And do I need really to make? No, probably not. And then I will take the old tuple, tuple pointer, sorry, tuple type, old tuple, and that would be the reference, and that would be tuple pointer, and old tuple, and then indices. Oh, since we are not passing, yeah, we won't be able to do that because here we pass in actual indices already. Oh yeah, okay, actual indices. So we would have to do indices like this, and we can remove this crap because that's not correct. Indices and old tuple, and here is an expansion, old tuple. So just an example, and let's hope it compiles, and obviously it doesn't. Make a tuple. Maybe we have to provide like a tuple type. Okay, so let me take a look at the example then. Auto make tuple, all tuple, and we use indices. Yeah, we are not passing an actual index sequence. You would have to pass an actual index sequence. Although I don't fully understand why do we have to pass. So the compiler knows how to make index sequence. We don't even have to do that as well. Indices, make index sequence. The tuple type, maybe that one can be eliminated as well. Let me try. No, it cannot deduce a type. Identify not found. Okay. Let me just comment out. No matching of a loaded function found. Cannot be used before it is initialized. Thread procedure, maybe we have to pass tuple type. Yeah, that solves the problem. So pass in an index sequence, and then we make in the sequence, we pass in here. Okay. So, and here, yeah, we can actually just use as an example, and tuple type, new tuple, and then we make tuple, but we don't have all tuple. We don't have all tuple here. Tuple type, tuple. Yeah, it won't compile. Obviously, it will. Oh, yeah, it is. It will. It will compile. Then that would be a reference, and then we create a new tuple out of it. And then here we can pass tuple pointer like this. Oops. Okay. Now So we have indices and have a tuple, but we have an error for some reason. Binary tuple type does not define this operator. Okay, because we can create out of an array a tuple. Okay, doesn't matter. I just want to show you an example how to do this, but we can take it to like another video. It's not that important, and I'm running out of time because I only have like 30 minutes left. So I want to like go through it again and polish all the things that I have. So yeah, it's not necessary. Like, I hope you understand the idea. Let me just throw and then we release. So that should be correct. That's correct. We can remove this crap here. I'm not even sure. Probably we can do this because we always pass in the procedure, so we can't reference. It is safe, right? We don't need to assert. We can remove std, and we can do that as well. Std call, and actually std thread is very similar, but it uses some other functions instead. Like, yeah, I can show you. Maybe I will be able to find. Yes, so begin thread and end thread. So if you replace this implementation with begin thread and end thread, it will be exactly the same as std thread, and it will be cross-platform. But I just want to make like Win32 API Windows specific version of std thread. And we have to release the pointer, the unique pointer, but wouldn't it be released when we get out of scope? Let me just check that. Throw an exception. Okay, so let me compile and see. Old tuple, okay. We don't need that. Yeah, everything compiles. Let me put a breakpoint here. Okay, and the thread with an ID is running, so that's the ID of the thread 3736 30,000. Okay, and we have to obviously release the pointer. Yep, and then we run the procedure and everything works fine. Here is our string and 5. So we need a little bit of polishing, I assume. So we don't need this, really. We can have a default constructor. So we forward all the arguments and we delete that. What are you complaining about? This kind of function should not throw. Okay. Okay, create thread. Are we using it somewhere? No. We are not. Yeah, actually, I will remove that. So it's nice and clean. For example, I can remove that function. Okay. So the default constructor. And then we have a create thread procedure. And then create thread procedure and the thread procedure itself. Um, mm, identifier not found. Okay, we can remove that. And yeah, okay, we can remove that. And compile and see. Okay, so we have a lot of warnings. That is not found as well. Create thread procedure. I don't see where does the error come from. Okay, so here, create procedure. Redefinition. Okay, so that's our actual. Yeah, I will mark it as this thread broke and then create thread broke. So just to make sure that they are private, but I will put them as private as well. Okay, and the procedure, that has to be the thread procedure. That should compile fine, although we have one error. What about now? We have some warnings, but that's fine. And just to make sure that everything works correctly, and yes, it does. Let's try. Yeah, we'll try to move some ownership, but right now we are able to assign like arbitrary lambdas. And let's quickly make a class out of it. So private. We have some types here. Okay, so that should be private. And that should be private. The create procedure should be private as well, but then public, and wait for a thread should be okay. So this has to be moved as okay, so the current, this one is static, should be public. System course should be public, is finished, should be private though. So I will move it. Is finished private, and everything else is public, so that's great. And the thread, the data itself, I think we can put it here. Okay. It's not actually, yeah. Let me think. Yeah, we can put it at the end. We can put it at the end, that's fine. Yeah. And we're running correctly. Yeah, let me just do a couple of tests, some minor tests like moving the ownership. Thread proc1 and let's just test when we don't have any arguments, and for example the return type is return 0, and we will print like the thread ID only, and all. I didn't even know that in C++ standard library there is like a AND function, whatever it does. So we only need to do that. And what are you complaining about? I don't know. Syntax error, missing semicolon. Ah, okay. And yeah, what I will try to do is I'll try to do this. So Win32 thread 1 equals, and I will try to move an ownership thread procedure 1, and then this, and I will wait for the thread to finish. I will wait for the thread to finish, and that would be correct. So here I'm moving the ownership, and I will put a breakpoint here. Okay, so we executed the function, but why we... Am I completely... Why are we hitting the breakpoint here? That is strange. That is strange. Oh, right, because... Yeah, and we don't have to move here. That's correct, because it's a temporary, it's R value, right? And we're printing out everything, but I wonder why we are not hitting the breakpoint. As far as I know, this should be called. So this is deleted. That is strange. Okay. Yes, okay. Okay. Oh, maybe we cannot just step. What if we do, so we waited for the thread, and then we created a new one, and then we just saying, okay, thread, and then some reason it doesn't want to put a breakpoint. Yeah, okay, so that's what we're doing. Am I running in release? No, it's in debug. So here's everything correct. But what if I... Okay, yeah, I just want to... I just want to do this. Thread 1. Okay, well... Yeah. Should work fine, and okay, and then we're calling. Yeah. Okay. Yeah, so I assume everything works correctly, just I couldn't hear the breakpoint because I didn't have a usage case. I will be finishing for today, and I hope it was interesting. Yeah, I don't know, actually, do I really want to publish it somewhere? I could, like, if you want, put a link into the description of the video, like a link to GitHub or something, but like, that's an actual class. You can always follow the video and implement it. And there's nothing like complex here. Obviously, you have to play around a bit with if you want, like, to support an ability of passing arbitrary lambda functions as a thread procedure. You have to go through the process of creating like a tuple, and then unique a pointer, and then playing around with indices. But once you're done, you get a pretty like decent implementation of std thread. Yes, I hope that it was helpful for you, and see you in the next video.